you'll feel warmer.
You're right. That always helps. Although, I'm not sure why.
When you rub your palms together, there is friction between the surfaces of your palms. That gives them warmth.
I had the impression that friction was a bad thing.
It depends on the circumstances.
Meaning?
See, basically, friction is a force that opposes the relative motion between two objects in contact. This friction produces heat between the surfaces of the two objects that are in contact and in relative motion. That's why you feel warmer when you rub your hands together. Friction exists between two surfaces due to irregular or uneven surfaces, interlocking of micro-level surfaces between two surfaces, and plowing of harder surfaces into the smoother surfaces. Friction also causes wear and tear of parts in machinery or even in the sole of your shoes. Remember how you discovered a hole in your shoe and had to buy a new pair?
Yes, I do. So the hole in the sole of my shoe was a result of friction?
Yes, a result of friction between the sole and the roads that it came in contact with. Now, do you see James kicking the football? Why do you think the ball stops rolling slowly after traveling some distance? When James kicks the ball, the frictional force acts in a direction opposite to that of the force applied. This frictional force stops the ball in motion gradually over a distance.
Does the force of friction always oppose the applied force?
Always. So, if we apply force on an object from the right to the left, then the friction acts from the left to the right and vice versa.
Mom, there is no traffic on this road. Can I just go home skating?
You won't be able to skate on the road. The surface of the road is uneven. So, there will be a lot more friction against your skates than in the skating rink. You'd better come with me in the car.
Oh, that man almost had an accident.
Yes. I saw an oil spill on the other side of the road. It has made the surface of the road slippery.
But shouldn't friction have stopped the bike?
Well, you see, oil reduces friction on a surface. That's why the biker had a problem. The tires on his bike couldn't retain their grip on the road.
So, friction is affected by the surface on which an object is moving?
Well, yes. That's one of the factors that affect friction. Let's see how the smoothness of a surface affects friction through an activity. We will need an examination pad, a pencil of cylindrical shape, a smooth glass sheet, and a ground glass sheet. Now, supporting the pad with a wooden block, make an inclined plane. Mark a point on the pad and roll the pencil down from this point onto the smooth glass surface of the table. Note the distance the pencil traveled from the bottom of the incline to the point where it stopped on the smooth glass surface. Now replace the smooth glass sheet on the table with a sheet of ground glass. Again, roll the pencil downwards from the same point marked on the pad. Note the distance the pencil travelled from the bottom of the incline to the point where it came to rest on the ground glass surface. What do you observe?
The pencil has travelled a greater distance on the smooth glass surface. So the smoothness of the surface does affect friction?
That's right. You see what I mean now? Smoother the surface, lesser the frictional force.
But why is the surface so important in determining friction?
Friction is a result of irregularities in the surface of the bodies in contact. Even the surfaces of the bodies that appear smooth to us have tiny irregularities. When one body is brought into contact with another, the irregularities on both the surfaces get interlocked. The interlocking of these irregularities of both the bodies gives rise to friction. To move any of these bodies, force has to be applied to overcome the interlocking. Now, think of rough surfaces, such as a gravelled road, which have far more irregularities. Can you imagine how much force will be needed to overcome the interlocking between the rough surfaces?
I can see why you said I couldn't skate on the road.
Now, try pushing this single chair.
Here you are.
Okay. Now try pushing this couch, a 3-seater.
Oof, it is so heavy.
Right. You will need to apply more force to move the couch than that required to move the single chair. The weight of the object leads to an increase or decrease in the frictional force. Heavier the object, harder are the irregularities on the surfaces in contact pressed together. Let me show you what I mean through a small activity. We need 2 wooden blocks, 2 pieces of string and a spring balance.
A spring balance? What do we need that for?
A spring balance is used to find the weight of an object. Weight, if you remember, is nothing but the force exerted on an object by the earth. The spring is stretched when an object is hung to the hook of the balance. As the spring stretches, the pointer on the spring balance is pulled down on a graduated scale, and the pointer reading indicates the degree of force applied on the object. Here are 2 wooden blocks. One weighs 1 kilogram and the other weighs 2 kilograms. Let's tie one end of the string to the block weighing 1 kilogram and the other end to the hook of the spring balance.
Done. What now?
Pull the handle of the spring balance to drag the block on the table and make a note of the reading when the block just begins to move. Next, we repeat the same process for the block weighing 2 kilograms. What do you observe from the readings?
The reading for the block weighing 1 kilogram is 1 unit on the spring balance. However, the reading on the balance for the block weighing 2 kilograms is 2 units.
The readings noted on the spring balance during the activity show that the force required to move objects varies with their corresponding weights. Hence, the weight of an object does not affect friction. Do you remember when we went to the park last time? how your little brother Tom loved playing on the metal slide.
Oh yes, but then he wanted to slide down the cemented slope as well and tore his shorts in the process.
But the inclination of both the surfaces was the same, right?
Yes, it was.
Then why do you think he wasn't able to slide down the cement slope easily?
Because the cement slope was rougher?
Exactly. However smoothly cement is laid, it will never become as smooth as metal. Rougher the surface, greater the friction. Let's continue with the previous activity to understand this better. Here, we use the wooden block weighing 2 kilograms. We know that the reading of the spring balance when the block was dragged on the glass table was 2 units. Now let's remove the glass sheet on the table and carry out the same activity on the wooden surface of the table.
The spring balance reads 3 units.
Now, let's spread my stool on the table. What is the reading now?
The spring balance reads 3.5 units.
With the same object. The readings noted on the spring balance varied every time we changed the type of surface on which it was dragged. This proves that the type or the nature of the surface also affects friction.
So the factors that affect friction are the smoothness of the surface, weight of the object, and the nature of the surface.
Yes, that's right. Tina, lunch is ready. Can you move the TV trolley a bit so we can both see it easily from here? We can watch the cricket match as we eat.
Sure, no problem.
It's easy to move the TV when it is on a trolley, isn't it? Imagine trying to drag it across the floor.
You're right. It is easy to roll the trolley across. It would definitely be tough to drag it. Does friction reduce when I roll the trolley?
Well, yes, rolling friction is less than sliding friction.
You mean there are different types of friction?
Definitely. There is rolling friction, static friction, and sliding friction. The force that resists the relative motion when an object rolls over the surface of another is called rolling friction. You can see another example of rolling friction in a marble that rolls across the floor.
Okay, and what about the other 2 types?
Try moving that carton to the right. What was easier? To move the carton from rest or to move it when it was already in motion?
Well, it was a little tough to start moving it. But once it started, it was not so difficult to slide it across.
Well, there you go. The force that you had to exert to get the carton moving is the measure of the static friction encountered by the carton. On the other hand, the force that you expended to keep the carton moving with constant speed is the measure of the sliding friction encountered by the carton. Can you tell me how these frictions compare?
Well, going by what we discussed, rolling friction is a little less than sliding friction, which in turn seems to be less than static friction.
That's right. You need lesser force to keep sliding the table than to move it from rest. And you would need even lesser force to keep it moving if the table had wheels. When an object is sliding, the tiny irregular points on its surface don't get time to interlock with the ones on the surface that it is sliding on. That's why you encounter lesser friction while sliding.
Right. I think I want one of those new school bags with wheels. It will become so much easier to carry my bag around when I'm rolling it.
Tina is helping her mum make dinner. Let's see what's happening here.
Tina, can you give me a glass of water, please?
Here, Mom. Oops, it slipped.
Oh ho, I'm afraid I had cooking oil on my hands.
Oil on your hands made the glass slip?
That's right. It happened because oil acts as a lubricant. The oil on my hands reduced the friction between the glass and my hand. So, I could not retain my grip on the glass.
So lubricants reduce friction?
Yes. In fact, any substance that is introduced between two surfaces in contact to reduce friction is called a lubricant.
Oh, that's the reason why gymnasts apply some coarse substance on their hands.
That's right. It increases friction and enables them to grip the beam better. In fact, friction is required to enable us to perform many tasks in our daily life. Remember the wet floor caution sign? Why do we need to walk carefully on a wet floor?
Because the floor becomes slippery due to water and we may fall down.
Right. Think what would happen if there was no friction. For example, we couldn't hold anything, as we need friction between our hands and other objects to help us grip them. We couldn't move around. We need friction between our feet and the floor to save us from slipping. We wouldn't be able to use erasers because it is the friction between the paper and the eraser that helps remove pencil marks. And moving objects would never stop.
Life would be really tough without friction. I was under the impression that friction was not good for us.
Well, friction is undesirable in many cases as well. For example, it makes things wear out. Stuff like your shoes, you know? The shoes that you had to discard were worn out due to the friction between them and the surfaces that you walked on. It makes doors and windows jam. That's why you hear the creaking sounds when you try to open a jammed door or window. On the other hand, friction is vital in some cases. In your bicycle brakes, for example, to make your bicycle stop when you want. Applying brakes creates friction between the brake pads and the wheels and makes the bicycle stop. You wouldn't even be able to write with a pen or pencil if there was no friction between pen and paper. Therefore, you can say that friction is a necessary evil.
This brings us to the end